Hello students, welcome to the video class for the subject Generation, Transmission and Distribution. This is for 4th semester Diploma Electrical Engineering students. So today we will start with chapter 3 overhead lines. So today our topic is discussion topics are types of support, size and spacing of conductor. Under this we are studying about different components of overhead lines. Then we will discuss about the different types of conductor materials, then different types of cross arms. Okay, so these things we will discuss in today's class. So types of support, size and spacing of conductor. So first of all we will discuss with the main component of overhead line. What are the main component for the overhead line? Okay, so the main components are conductors. See, if this is a conductor and this is another conductor, this is another conductor. See, this is a pole, like this structure is, these are the three conductors. You can see like this, there is something, the structure is like this, there is also something, the structure is like this. Wait. So the structure is like this. Okay, so the conductors are like this. Okay, so see, here the main component is conductor, then supports, then insulators, then cross arms and other miscellaneous items. Okay, so overhead line may be used to transmit or distribute electric power. You already knew. So for the successful operation of an overhead line depend to a great extent upon the mechanical design of the line. So while constructing an overhead line, it should be ensured that mechanical strength of the line is so as to provide against the most probable weather condition. So see main component, this is the conductor portion, this is conductor, this is conductor, then this is the support, this is the support, this is like a pole or like a tower. Okay, then this is the insulator, this is the insulator thing, this is the cross arm. Okay, this is the cross arm and miscellaneous items. Okay, that is a phase plate, danger plate, phase plate, lighting arrestor, anti-climbing wire, etc. So first we will discuss about the conductor material. Okay, so before going to different types of conductor materials, we have to know the properties of conductor material. Okay, the conductor is one of the important item as most of the capital outlay is invested for it. Therefore, proper choice of material and size of conductor is of the considerable importance. The conductor material used for transmission and distribution of electric power should have the following property. That is the higher electrical conductivity, high tensile strength in order to withstand mechanical stress, then low cost because it is used for long distances, then low specific gravity so that the weight per unit volume is small. So see, conductor, it is a one important item which is used, okay, which is used for transmission distribution purpose. So actually the overall capital cost, okay, invested in a transmission line or distribution line mainly depend on this conductor material. Okay, mainly depend on this conductor. So that's why we need to take care for the proper choice of material and size of conductor. Okay, so these are the conductor properties, because that are it has high electrical conductivity, high tensile strength to withstand mechanical stress, it should be low cost because it is used for long distance. We have to use more quantity of conductors, that so that it should be low cost, then low specific gravity so that weight per unit volume is minimum or small. Okay, so these are the properties which we should take in care. So commonly used conductor materials are your copper, aluminium, steel, cored aluminium, galvanized steel, cadmium, copper. So these are the commonly used material which we will discuss one by one. So first one is the copper. Okay, copper is an ideal material for overhead line owing to its high electrical conductivity, because copper has high electrical conductivity and greater tensile strength. It is always used in the hard drawn form as standard conductor. Okay, hard form of copper is used as standard conductor. Okay, because the strength, because the copper is a very what it is kind of very loose material, because means it has it's what means it is very reliable. Okay, it is very soft, so it should be in hard drawn form. Okay, okay. So copper has high current density, that means current carrying capacity of copper per unit of cross section area is quite large. Okay, so this leads to two advantages. What? The smaller cross sectional area of conductor is required, because its current density is high, so it requires smaller cross section area. Okay, and then second advantage is the area offered by the conductor to wind load is reduced. Okay, so if we are using smaller cross sectional area conductor, then the area uh, offered by the conductor to wind pressure is obviously reduced. Okay, then the next, but what is this? See, this metal is quite homogeneous, durable, and has high scrap value. Okay, because if the conductor quality is reduced and if we want to change the conductor material, we have to implement new conductor material. Okay, then we can't throw the copper conductor like this. We can sell this copper conductor. Okay, because it has high scrap value. Okay, it is durable, it is quite homogeneous. Then the next one is aluminium. So aluminium is a cheap and light. Okay, cheap and light as compared to copper, but it is much smaller conductivity and tensile strength. It has smaller conductivity and small tensile strength to the mechanical stress. Okay, so the relative comparison of the two material is that the conductivity of aluminium is 60% of that of copper, and the smaller conductivity of aluminium means that for any particular transmission efficiency, the cross-section area of conductor must be large in aluminium than that of copper. Okay, so because its conductivity is smaller as compared to copper, that means the cross-sectional area requirement for this conductor to achieve to achieve a particular transmission efficiency, that means here the area of cross section requirement is greater or larger as compared to copper to achieve a particular transmission efficiency. So for the same resistance, the diameter of aluminum conductor is about to 1.26 times of that of the diameter of copper. Okay, so the specific gravity of aluminium is 2.71 gram per cc, and which is lower than that of copper. Okay, so therefore aluminium conductor has almost one half the weight of equivalent copper conductor. So its specific gravity is minimum as compared to copper. That's why, so whatever weight of the when we are taking copper conductor, so whatever is the weight as compared to this copper conductor, the aluminium conductor has almost one half of the copper conductor weight. Okay, so for this reason, the supporting structure for aluminium need not be made so strong as that of the copper conductor. Okay, that means the supporting structure means the your pole or tower. Okay, so the supporting structure for aluminium need not be made so strong that of the copper. In case of copper conductor, supporting structure should be strong enough, okay, to withstand the stress, but in case of aluminium conductor, the the supporting structure might not be strong. It need not require to be strong supporting structure. Okay, so aluminum conductor being light and is liable to greater swings, and hence larger cross arms are required. So see, this is the cross arm and these are the conductor. Okay, like this. So aluminum is very light, so whenever there is a wind flow or wind pressure, there is a greater swing. Swinging means like this. The conductor swing here and there. Okay, so the swinging of conductor is greater here. That's why larger cross arm required, because when there is larger cross arm, the conductor swings here and there. So these two conductors will not come in contact with each other. Okay, because when the two conductor come in contact, then there will be a short circuit problem. Okay, so due to lower tensile strength and higher coefficient of linear expansion of aluminum, the sag is greater in aluminum conductor. So what is this sag, we will discuss in the next later part. You just remember over here, it has low tensile strength and higher coefficient of linear expansion. That's why here the sag is greater. Then the next material is the steel cored aluminum. So due to low tensile strength, aluminum conductor produce greater sag. This is one problem. So this prohibits their use for larger span and makes them unsuitable for long distance transmission. Okay, so in case of aluminum conductor, there is low tensile strength. That's why it produces greater sag. So due to this problem, this type of conductor may not use for long distance transmission. Okay, so in order to increase the tensile strength, the aluminum conductor is reinforced with a core of galvanized steel wires. Okay, so the composite conductor thus obtained is known as steel cored aluminum. Okay, steel cored aluminum, and is abbreviated as ACSR, aluminum conductor steel reinforced. Okay, so like this, say in the middle there is a steel core, and surrounding this, these are the aluminum conductors over here. This is called ACSR, steel cored aluminum. Okay, aluminum conductor steel reinforced. So steel core aluminum conductor consists of one central, this is the central core of galvanized steel wire, surrounded by number of aluminum, this is the number of aluminum strands. Okay, these are the number of aluminum strands. So it is like this, one conductor should be like this, means it is like a bundled conductor. Okay, this total form one conductor. Okay, so usually the diameter of both steel and aluminum wires is the same. The cross section of the two metals are generally in the ratio of 1:6, but can be modified to 1:4 also, in order to get more tensile strength for the conductor. Okay, so in this figure there is one steel cored aluminum conductor having one steel wire surrounded by 6 wire of aluminum in this case. Okay, so the result of this composite conductor is that steel core takes greater percentage of mechanical strength, while aluminum strands carry the bulk of current. The steel core aluminum conductor have the following advantages. What are the advantages? See, the reinforcement with steel increases the tensile strength, but at the same time keeps a composite conductor light. Therefore, steel cored aluminum conductors will produce smaller sag, and hence longer span can be used. Okay, so by the reinforcement with the steel core, this increase the tensile strength. Okay, at the same time this keeps a composite conductor light. Therefore, steel core aluminum conductor will produce smaller sag, and hence longer span can be used. For long distance distribution line, we can use this type of conductor. And due to smaller sag with steel core aluminum conductor, tower of smaller height can also be used. So this is the conductor and these are the support. So if the conductors swing like this, This is your our clearance between earth and conductor. So if it is swing like this, then there is the less clearance, so we need to increase the pole height. And if there is a lower sag, then at that time the clearance is sufficient, so in this case we need not to extend the pole height. Clear? So due to smaller sag with steel core aluminum conductor, tower of smaller height can be used. Then the next one is the galvanized steel. So steel has very high tensile strength. Okay. Therefore, galvanized steel conductor can be used for extremely long span or for short line sections exposed to abnormally high stresses due to climatic condition. Okay. So when there is a very high stress, steel conductor is used because it has very high tensile strength. So they have been found very suitable in rural area where cheapness is the main consideration. So due to poor conductivity and high resistance of steel. Okay, steel has poor conductivity and high resistance. So such type of conductor are not suitable for transmitting large power over long distance. So however they can use to advantage for transmitting small power over a small distance where size of the copper conductor desirable from economic consideration would be too small and thus unsuitable for use because of poor mechanical strength. Okay, so galvanized steel can be used for small distance case. Okay, for transmitting power in small distance where the size of conductor is very small. So in this case we can use galvanized steel with rather than copper conductor. Okay. So the next one is the cadmium copper. The conductor material now being employed in certain cases is copper alloyed with cadmium. That means addition of 1% or 2% cadmium to copper increases the tensile strength of, okay, about 50%, and the conductivity is only reduced by 15%. Okay, in case of pure conductor, what the conductivity is greater but the tensile strength is low. So when we use the alloy of copper, cadmium copper, here the conductivity is 50%, but conductivity is reduced by 15%, but tensile strength increased by 50%. Therefore cadmium copper conductor can be useful for exceptionally long span. Okay, however due to high cost of cadmium, such conductor will be economical only for lines of small cross section. Okay, see, cadmium is not economic, its cost is very high. Okay, that's why such type of conductor will be economical only for the line of small cross section where the cost of conductor material is comparatively small compared with the cost of support. Okay, and the next part is the line support. What is the role of line support? See, the supporting structure means what? The supporting structure for overhead line conductor are various types of poles and towers. Okay, these poles and towers are called as line supports. So these have the following properties. What are those? High mechanical strength to withstand the weight of conductor and wind load, then light in weight without the loss of mechanical strength, cheap in cost and economical to maintain, then longer life, easy accessibility of conductor for maintenance. So these are the property of line support. So we are using different types of line supports like your wooden poles, steel poles, RCC poles, lattice steel tower, etc. Okay, so the choice of supporting structure for a particular case depend upon the line span, cross section area, line voltage, cost, and location or local condition. Okay, so different types of supports are discussed over here, like wooden poles. Okay, so the main object of wooden supports are tendency to rot below the ground level, comparatively smaller life, cannot be used for voltage higher than 20 kV, less mechanical strength, and require periodical inspection. So these are the main points or main objections for wooden support. You have to study all these are all theoretical parts. I just mentioned the key points for different structure of different types of supports. You just go through this video, okay. So first line support is the wooden pole, and then next is the steel pole. Okay, steel pole are mainly used as compared to wooden poles because it has greater mechanical strength, longer life, okay, and it can permit longer span to use. Okay, such poles are generally used for distribution purpose in cities. Okay. And for the this type of support, it need to be galvanized or painted in order to prolong its life. Then the next one is the RCC pole or RCC tower. Okay, this is one another type of line support. Just go through this video, these theory parts. And the next part is the steel tower. Already you saw various types of steel towers in your surrounding, okay. So for long distance transmission at higher voltage, steel towers are employed. Okay. Steel towers have greater mechanical strength, longer life, can withstand most severe climatic condition, and permit the use of longer spans. Okay. The risk of interrupted service due to broken or punctured insulation is considerably low in this case, so it is used in longer spans. Okay, tower footing are usually grounded by driving rods into the earth. This minimizes the lightning trouble. Okay, so these are the different types of line supports. Okay, so just go through this theory portions and understood what is the different types of line supports, what are the properties of the different types of line support. Okay, so this is all about your different conductor materials and different types of line supports. Okay, in the next class we will discuss about the types of insulator. Okay, so thank you all.